Ma'am, I was just feeling that, one or like two homework is good enough, 2 to 3. More
Mm-hmm.
than that, it sometimes becomes like overwhelming. Oh my God, itna kaise karenge? Like that.
Yeah, that's right. And I never tell you to do the homework like in a proper homework way. Okay. It's just like you visit the question, you give your thought process, and that's it. Like, I am never demanding you all that, okay, this should be completed or that should be completed, right? And
Mm.
why I'm giving this, because if a day before you give it a thought, then it will be like that, okay, you saw the question, you went through it, you will be having some thought process going behind it. Okay, the process is good, because if directly I just tell you, okay, this is mirror of a tree, that this is like this, you apply LDR, DLR, or LRD, solution will be done. So you didn't put your thought process in it, I just told you, you just accepted it. So that is not how DSA goes, right?
Yeah, yeah, yeah. So thought process, like verbally, we can orally we can say, oh, ye kar denge, ye kar denge. This is fine. But yeah, when it comes to the
Correct.
details, then it
And
becomes.
as you would have noticed earlier in our sessions, it used to be like that, that you must be like, this is something I've seen in most of the students. They say that, ma'am, okay, we are getting it. We we can say that, okay, this can be done in this way. But when it comes to writing the program or writing the code, we are blank. Did this thing came to you guys?
Yeah, it
Yeah.
always happens like that.
Yeah,
Yeah.
but now it would have improved, because now I always tell you guys, think of a brute force. Okay, think of a brute force. Think how you are gonna make the solution work. Okay, maybe it can be the most like the solution with the most time complexity, but you should have a coded solution. Okay, so these are few things which this course brings into you. Okay, so yeah, that's why I just gave you all these homework. I could have explained you on the spot, but we have very limited time in the class. So it was better like I should give you few questions, you think of it, and then we'll come. Okay, is BST, is it done? Is BST is not done. Okay.
No.
Okay, cool. What should be the return type of its function?
Boolean.
Boolean, right? Because it is just telling you that whether it is a BST or not a BST. What should I pass in this? I should pass root node, correct? Only this will be given to me in the question.
Yes.
Okay. So to find out it is a BST or not, what is the characteristic of a BST?
I mean, to the left should be smaller element. To the right, it should be bigger than the data element.
So basically, if I write all the nodes together from left to right, then it should be in a sorted order, like from the left, small, small, small numbers, then root, and then all the big numbers. It will be a kind of sorted array, sorted list. Yes. Which traversal technique gives you a sorted list from a tree? Yeah, right. In order. So if you do the in order of this tree, you will be getting it as, I'll just like right now here, I'll get 8 first of all. No, not 9, 8, then 9, then 10, 13, 14, 15. Then coming over here, I'll get 19. Then I'll get 28, then 30, 33, 40, 42, and 49. Correct? So if you find out the in order traversal of a BST, you're going to get a sorted list, right? So to figure out if the given tree is a BST or not, we can have the in-order traversal. If in the in-order traversal, like you just find out this list. Okay, after finding out the list, you can check if it is sorted or not. Clear? Approachable solution. Yes. Time complexity, guys. Time complexity for this. Why n log n? Are you sorting it? Are you trying to sort it via some sorting techniques? No. So why will it take n log n? Then it's order of n. Okay. Space complexity. Order of n. Okay. So basically it's like this solution will take order of n time complexity and order of n space complexity. Everyone agrees? Any other approach we can follow than this? Now you have got that we have in order. Any other approach you can do? Can you try to reduce the order of n space complexity to order of 1? Okay, I won't write the code here. I'll just write this is the first solution in order traverse. Using recursion, we will be using recursion only, right? For in order traversal. Then what are you saying that using recursion we can try? We are doing it using recursion only. I'm saying okay. The one thing which you can do with in order itself is right now you're storing the entire list and then checking that if it is gonna work or not. But you like for reducing the just a minute. For reducing the space complexity, can you do this comparison on the fly? Like instead of again and again storing it in the list and then checking if the list is sorted or not, can you do that thing on the fly? Yes, right? You reach extreme end, you make this as minimum. Then you go here, then you get a, and you can like keep on comparing the numbers at the end. Like if any of the, like you can say this link is disturbed in the middle, then you can just stop it and say that it is not a BST. Are you guys able to follow?
No, madam.
See,
Sorry.
what you can do, you can maintain a maximum variable. Right now you will be getting it as 8 because the first number you will be traversing with in order is 8, right?
Yeah.
The next number you are getting it as 9, correct?
Yeah.
Yeah, your maximum is getting updated all the time, right? Again you got 10, then 13. So this will keep on going on, and if all the times you're getting the maximum numbers, that is every time your maximum is getting updated, this indicates that your tree is a BST. Are you able to follow?
Yes.
Then how can I say this approach is correct? Because let's suppose I'll just exchange these. you had traversal like this. Okay, you went to 15, it was fine, but as soon as you go to 14, which is smaller than your current maximum, that means in order is not getting followed, right? And if it is not getting followed, then you can say that it is not a BST. Is it clear?
Yeah.
Yeah, that's it. That's that was the only one thing you need to optimize, and your solution will work with order of one space complexity. Clear?
So in order combination with checking if the number is bigger than the previous number.
Yeah, you have to maintain, you can say, a kind of Boolean variable which will all the time tell you that, okay, the current number you got is like greater than the previous number. If in any case the current number is smaller than the previous number, it indicates that it is not following an in order traversal. Clear?
Yes.
Yeah. Okay. Now we will come on. So I'll just write here, maintain a temporary variable and reduce the space to order of 1. So here the solution is the same. So your complexity here will be order of n and your space complexity will be order of 1. Clear, guys? Now coming on to the third solution. If you see the tree here, what is the range of your leftmost tree? Like from which to which number your leftmost tree can have? Is there any range? Can I store 16 in my left side tree if my root is 15? No. Okay, 9 to 15. What if, sorry. So what if, like, you never know what is the range? You can say here the maximum range of this particular block is, like, the number should be less than 50. But you never know what is the minimum range. It can be minimum, yeah, right. It can be any minimum value, minimum integer value possible. So I can write here integer dot min value. Are you getting it?
Yeah.
Others. So this root node, it has no value, like no range. It can be any value, and based on the root, you decide your left subtree and right subtree. So its range extend between int dot min till int max. If I go here on the right hand side of 8, what will be its limit or range?
Less than 8.
On the right hand side, should it be less than 8?
No, no, no. Right hand side, it could be below 15.
It should be greater than 8 and
Less than 15.
less than 15. Correct. If I go to the 10,
So left would be always less than 10 and right would be
less than
between 10
10,
and 15.
we are at 10. So what should be its range?
Oh, so range of what? Left element or the right element?
The one I am pointing to, like 14 is number between 8 to 15. This is its range, right? It belongs
Oh,
to this
okay.
range.
Okay.
So 10, what will be the range?
So,
It should be less than 40, right? Because
yes.
it is going on the left hand side. And since it is on the right hand side of 8, the number should be bigger than 8 always. So its range is 8 to 14, not integer meant to 10 or something. Clear?
Ma'am, I have one doubt here
Mm-hmm.
that when we are populating 10 or 9, then ideally it should be to the right of 8. Like the grandparent of 9
See,
is 8.
this tree is not made according to
Mm.
the numbers in the ascending order. Okay. In the array 15 came, I took it as a root node. Next number 8 came, I arranged it to the left. Next number 14 came, I arranged it to the right side of right side of 8. So this way it is coming. Okay. It's never like ascending or descending order. Clear?
I have one question, like, is it a binary BST? Because why I ask this question is 8 is above and 9 is, which is higher, is below to the
See, Anatan,
left.
the thing is 15 came,
Correct.
it became this root node. Okay. Then imagine 8 was the next number in the array. We arranged it to the left side of 15. Clear?
Correct.
Now our next number came 14. 14, where can it be arranged? Can it be arranged on the left hand side of 8?
No, no, right.
Right. We arranged this. After this 10 came. Okay. So 8 is already there.
Right.
Yeah. 10 is smaller or bigger than 8?
Mm,
10
10 is
is
bigger than 8.
bigger. So it will go to the right. When it went to
Yeah.
the right, it saw 14.
Yeah.
So 10 is smaller than 14 or bigger than 14?
Smaller.
Smaller. So it went to the left hand side of 10.
Yeah.
Clear? Then
Yeah.
came 9. When 9 came, is 9 bigger or smaller than 8?
Smaller.
Smaller.
Yeah. It's
9
smaller
is,
than 10. Oh,
I'm talking
yeah.
about 8. It
Oh,
is
bigger
bigger
than 8.
than 8. Again, it will go to the right hand side.
Yeah.
Now here 14 is there, right?
Right.
So 14 is bigger or smaller?
Bigger than 8.
Bigger than coming number 9, right?
Yeah.
So
Yeah.
9 cannot go on the right hand side of 14, correct?
Correct. Correct. Correct.
We will redirect it to the left hand side. On the
Yeah.
left hand side, 10 is already there. So 9 is smaller than 10, correct?
Yeah.
So we arranged it on the left hand side of 9.
Yeah.
Clear?
So
So
process of insertion is clear to me. Process
yeah,
how we are inserting is clear. But is it a binary search tree? Why I ask this, because 9 is bigger and it's no, I think it's fine. It is still a binary.
see, 9 is bigger, it's correct, but 9 is on the right hand side of 8. Okay,
So it is fine. Yeah.
it is fine. Clear?
Yeah.
Yeah. So you all got the range idea what I was talking. So similarly, you can write the range of all the numbers. If you want, like quickly, you can fill this up. Here, the range will be, it should be bigger than 15 and it can go till int max. Here, the range should be here the range should be that the number should be greater than 15 but should be smaller than 28. Here the range should be number should be bigger than 28 and it can go till
Not
int
max.
max. Correct. Here it should be I guess 15 and 42. Here it should be, I guess,
In
it's yeah. What will be its lower limit?
15,
15. Upper limit?
42.
No, it should be 33 because it is
Okay.
going on the left side of 33, so it should be smaller than 33.
Right.
Here it should be
The lower limit should be 33 or more.
yeah, correct, and it should be smaller than 42.
Yeah.
Clear? For 49,
Yeah.
15.
42.
Oh, sorry, my bad.
Yeah, 42 or integer dot max.
Correct. 42 and int max.
So for the extreme left one, the 9 one
Mm-hmm.
should be 8 to 10. Okay, extreme left one.
Correct. It should be greater than 8.
Yeah,
Got it?
yeah,
Okay. So was it easy?
yes.
Yes. Can we solve our question in this way?
Which question? Like how to find range or
Is it a BST or not?
okay,
This is the question, right?
yeah.
Yeah. How to solve it? How are you gonna solve it? The question is that. If the root lies between the range, we can go inside left, right, checking the same. Correct. So I think it's gonna take you the same time, order of n, but it's order of one's place, which we already achieved, but it perfectly goes with the concept of BST as well, which are the ranges. Okay, so this is one of the interesting solution. You guys can try implement all these three solutions on your own because I don't think so any of them is tough, in order. And like this is the range thing, okay, comparison, greater than, less than, greater than, less than, and all obviously you will be traversing it in order fashion. So I don't think so my guidance is needed here for the code, but like if you guys are stuck anywhere, you can ask it in tomorrow's session.
Ma'am, one more thing. I followed that in order is easy and we can do it. But finding the range, how does it help in finding the binary search tree? Like,
See, every time the number you are getting is within the range that you are setting for that number, that means it is following a BST. If it is not in the range, that means it is not following a BST.
yeah. But it is
Clear?
just another way to solve the problem rather than a better way.
Yeah, optimizing the session. It's just like the way you read what is a BST. We are just using that concept of checking if it is a BST or not.
Okay.
Clear?
Yes.
Okay. So now this question was that you have been given a pre-order and in order, and you have to find out the post order, right? Any solutions for this? Yes. Okay. What is the solution for this?
So if we are given pre-order and in order, we have to find the post order. Is that the question, or are we given the tree and we have to find out the post order?
You won't be given the tree. You will only be given the pre-order and in-order arrays. That's it.
Okay.
Kishan, you have a solution, okay, that we can try constructing a tree. We know in pre-order we have first element as the root. No, I didn't try. Yeah, you didn't tried it, I know, but you just thought it. Okay, so this is one way and you are correct in that. You can try constructing a tree and you can then get a post order out of it, right? How much time will it take and how much space it's going to take? Space, okay, on space, how much? Correct, order of n space. I'll just write the solution name. First solution is try constructing a binary tree. Okay, so for this you will be taking order of n space. But how you will be forming your tree? Question is that. Using range and root. Okay. How will you get the range? How you are gonna get the root node? Range implementation I explained. Okay, but range implementation was like that your root node should lie between integer min and integer max. Okay, but here in the pre-order and in order, how will you identify what is your root node? Okay, so this is your root node. You got 15. Now what will you do with 15? You
I
know
didn't
that,
get
yeah.
I didn't get how to find the root node. It's not easy. Oh, okay. From pre, the first element would be root node.
Yeah, like pre-order first node, it's the root node, it's clear, and rest we can pick up from the in order. The concept is you know that your first node is your root node 15. You found out 15. You find out 15 in the in order, okay? Wherever you find out 15 in order, you know that it is a kind of a place where left subtree comes first, then root node comes, and then the right subtree comes, right? So you find out 15, then you will know the range. That is, this belongs to your left subtree and this belongs to your right subtree. Clear? Then the next you find out 9. Just a minute. You figured out 9 here. So you find out 9 here. So 9 is going to go on the left hand side of 15. Clear? Correct. Then you got minus 18. Again, minus 18 is there on the left hand side of 15. I'll just construct it simultaneously. You got 15, you got 9. See, Vishnu, you were saying why it is not in order. Now 9 came. So 9, I put it on the left hand side. Then minus 18 came. Then minus 18 is going to be on the left hand side of 9. Clear? Next coming is 7. 7 again is on the left hand side of 15. So you will be attaching 7 on the left hand side of 15 But can you see that 7 is on the right hand side of 9, correct?
No,
Sorry.
so no, there is something. So if you put 7
My
to the
bad.
right of 9, it's a problem.
No. My bad. Yeah, there is some problem. Let's make it as 17. I guess that will work fine. Yeah, I guess these are some random numbers, and like we have to form a tree out of. It's basically you have to find out a tree out of it. Okay, it's not something like a BST or what. I guess so. Just like
So if at
yeah,
all we have to make a
it's
tree,
just
so
it's just
supposing,
like yeah.
so ma'am, if we want to make a tree out of this, everything was going good until like if minus 18, after that 7 comes, then 7 would go to the right of minus 18. Then
No,
everything
the
looked
thing
fine.
is, okay, just give me a minute. Okay, the thing here is what I'm trying to say. It's not about a BST. This problem is only about traversals. Okay, so you found 15, you entered here, then you found 9, which is on the left hand side of 15, you entered. Then minus 18, you got, and minus 18 is on the right hand side of 9, right? Attached it in a wrong way.
No,
So
so
we will
supposing if it
attach
is,
it. Sorry.
no, supposing if it is minus 18, it will still be on the left because it is smaller than 9.
Vishnu, that's what I'm saying. This is a question for binary tree traversal, not for binary search tree traversal.
Okay.
Are you able to follow?
No. I mean,
Okay. See, what you
no.
are thinking is that on the left hand side, the smaller number should come. On the right hand side, the bigger number should come. Correct?
Correct.
That is a configuration for BST.
Yeah.
Okay. And for traversal or for like traversing in a tree, is it compulsory that you should always have a binary like binary search tree? Can't you traverse in a normal binary tree?
Yeah, we can do
We
on
can,
binary.
right? So in the given question, we do not have a binary search tree. We are
Mm.
only having a binary tree. Okay. So the way it is saying, just make your tree according to that. Like you found 7, 7 is on the left hand side of minus 18, right? So
Yeah.
7 will come here. Are you guys able to follow?
No, one thing is still is not clear. I know it's a binary tree, but the general rule is smaller should go to the left. So,
No, it's
oh,
not a general rule. It is a rule for binary search tree only.
okay. So, I mean, if minus 18 is going to the right, then what's the logic behind putting it in the right instead of left? Even,
Because you
Mhm.
found minus 18 in your pre-order array.
Yeah,
Okay. Then in your in order array, you found minus 18, which was to the right hand side of 9. Okay. That's why I kept it on the right hand side of minus, like right hand side of 9.
okay.
Sorry, Kishan, your question is not clear to me.
I'm saying if we are constructing normal binary tree, we can directly pull one element and we can place in left and right, left and right. We can do that. So right.
See, okay, you can do that, but up to when you will know that okay, I have to keep it on the left. You will take 15.
Beginning level,
Yeah.
like we can say root will be having level 0. After that, we can have 4 elements for the first level. We can have 4 into 2 levels at the second level. We should not go for like checking whether our left node should be left or like greater than, or our right node should be greater. We should not check if it is not a BST, right?
But why so? Like a normal binary tree should also be like is traversed in a pre-order and in order traversal, right?
That I'm agreeing with you. The thing is, in order in case of BST only will give sorted tree, right? Will give sorted array.
Yeah.
So if we are not following BST, then we need only one array, right? We
We
can
need one array,
we
which is
can
the
take the root
post order.
element, and
Mhm.
the corresponding element we can take, and we can start putting from left, right, left, right, left, right. We can start putting depending on level.
Acha, okay, I'll just take your thing and I'll just make it. Okay, then you will see the difference. I took 15, then 9. Then you're saying minus 18 should come here, correct?
Yeah.
Then 7, then 25, then 12, 2, then here it should come as 17, minus 4, 5, and 3, and here it will come minus 1. Okay, it's fine.
Yeah.
You take it in order now.
Okay.
It won't work. So we have to pre-order and in order. We have to find out the post order, which will go with both of these pre-order and in orders. Okay. And it's like binary trees never all the time about BST, especially when you're talking about traversals, because traversal can be done in any of the binary tree. Okay. It's not necessary. It should be a binary search tree only. Clear? That's why I'm just telling you how to position your elements. You found 15. I told you, okay, 15 is found. All the left side element of it are going to be a part of left subtree. All the right side elements are going to be part of right subtree. You found 9. You entered 9 on the left hand side of 15, as you can see. You found minus 18 in the pre-order. In the in-order array, it was towards the right hand side of minus 8, like right hand side of 9. So I kept minus 18 here. Next, I found 7. 7 is on the left hand side of minus 18. So you found 7 here. Next is 25. 25 is on the right hand side of minus 18. So 25. Same goes with these. You can form the tree and then you can take your post order. Are you guys clear with this? Not getting any response?
Yes. I mean, I'm clear that all to the left of in order, we are putting to the left, and
Kishan,
we
is your doubt clear now? Okay. How you got the clarity? You can explain it to the class because others will also like to hear that.
Like I didn't get clarity. The thing is, simply construct the tree depending on both the arrays, and at the
Yeah,
end
but
go for
you
the
should
post
have
order.
a strong answer that why the concept that you were thinking of forming a simple like left right numbers is not working out here.
No, actually, here we have two different arrays, right? So we need to go all together with two of them.
Yeah,
That is why we need to.
correct. If it would have been only pre-order, you
Then
can
we can go for
construct it.
two. Yeah.
Correct. But can anyone ever give you a pre-order and ask you to find out the post order of a tree? Is it feasible?
No.
No. So this is the solution to your question. Okay. Guys, can you try doing this solution on your own, or do you want the code for this? Can try. Okay. So this is a solution which is going to take your space a lot. Clear, everyone? Guys, there are 7 members excluding me in the class. Only 2 people are active. What about the rest? Are you guys just you came to hear my voice or hear this topic? No messages at all. I don't know why. Okay, I'll wait. Okay.
Ma'am, one question I had, but it's a very funny question. So in order, when we are moving from 9, so why didn't we put 7 next to 9? 7, I mean, just forgot, like, why we are not putting 7 to the left of 9 instead of under 18?
See, the thing is, you pick the number from pre-order array. Okay.
Yeah.
And then you position them according to the in-order array.
Yeah.
That is the solution to it. Though you can see in an in-order traversal, 7 is kept beside 9, right? But
Yeah.
if you see the pre-order array, you first have to position -18 and then only you can position 7. That's why it is placed in this way.
No. I sorry, didn't get it. So 15 is the root, then starting with 9, which is extreme left.
Mhm. Yeah.
Then
Why not 7 on the left hand side of 9? Right.
yeah, yeah.
Because -18 comes first in the
Okay.
pre-order array. Then we position -18. Okay. Then comes 7. When 7 came, we can see that 7 lies on the right, like left hand side of -18. So we kept it on the left hand side of -18. That is the answer to it. Clear?
I mean, not a sound, yeah, like not 100% clear. Unless I do
You
it couple
guys
of
can
times.
visit this question once more because I can see you guys are having a lot and lot of questions. I can completely understand that. And then you can come back to me. Like you can try implementing this solution today, and
Mhm.
then you can come back to me. Like if you have any questions or doubts or anything. Clear?
Yeah.
Okay. So I won't proceed in this question further because there is an optimized solution in this as well. But once you are done with this, then we will move ahead. Okay, this is on a pause. Guys, and this is a warning. Implement all the solutions today itself, whatever I have explained. Otherwise, you will forget it. Okay. The length of path between node A and node B. Now we are going to discuss this. Any approaches for this? Okay, Kishan, what is the approach you find out? One is get the distance from root node. That is the. But I told you that from the root node, it won't work. See, it will work when the path is crossing the root node. Basically, if I explain you all what Kishan's solution is, he's trying to say, try to find out the distance from root node till point A. Next, sorry, y1, y2, and y2. Next, try to find out the distance from root till B. So your path will be like you got your path from A to root. You got your path from B to root. Add the length of both of them and you will get it, right? This will work when they are crossing from the root node. But if you see this particular tree, A is here, here, and here. Okay, you go up till here. There is no requirement to go till root because when you just cross this node and from here you will be able to get to the B, right? So in this particular approach, we are not even touching the root. So it is not required always to touch the root node and then from B to root again touch and then add it. You guys can see this in the example, right? Like it is passing for one or few test cases, but it is failing as well for few test cases, right?
So yeah, I got this. I have one solution. So my thinking is pick up those two nodes and then try pre-order for both of them. And if we find any common intersection, like common node, then we just sum up the length. So I mean, I'll repeat, like pick up any two nodes, whichever has been asked as the parameter, and then traverse in the pre-order fashion.
Just a minute. Kishan, what you are saying is path to common parent. Okay. So, okay, you got the path to common parent as A, then this one. Okay. Then why are you saying common parent to root? Why there is a need to again go to the root node? Correct. So for that, and yes, Vishnu, how in a tree you can find out a pre-order for node A and then you can find out the pre-order for B? Pre-order is a traversal technique, right? It will cover the entire tree at once. How are you differentiating it?
I mean, my thinking was just go up and up and up, meaning what is the root of the given node until from both the ends until we find a common reference or the common hash code of both the nodes.
It's basically like you know the root node. Okay. So from root node, try to find out the distance till A. So if I do that, I'll get here x1, x2, x3. If I do it here, y1, y2. For A, it will be root, then x1, then x2, x3, and A. For B, the path will look like root, y1, y2, and B. Sorry, my bad. X1 will also come. Y1, y2, and B will come. Are you guys getting it? Now try to eliminate if there is any common node. Okay, so like I mean to say there should be only one common node between the path, which is connecting A till B. There should not be more than that common nodes. So you found root, okay, this is common. Then you go to the next node and see if these are common as well or not. If the next nodes are common as well, then you can eradicate these and then you will be getting the next common node. If these are also the same, like the next coming ones are also the same, then remove them and keep the next ones. Are you guys able to follow this? Like have the node or have the path from root node till A, have the root path from root node till P, but you should only have one common node. If there are more than one common node, then you first need to remove them and then you have to add the remaining path length and return the result. Make sense?
Yeah, I have a question on before coming to this point, we have to traverse to A. In order to traverse to A, we don't know where it is. So we are going to use in order or pre-order.
You will be knowing where is A because you will be given a number or something, like you can say you will be given a number and you have to search it in the tree to find out where is A.
So what the approach will we take? Like pre-order, post-order, in order?
That
How will
you,
that's up to me?
yeah, how you search it and how you search in a tree.
Yeah, I mean one of these three techniques.
Yeah, right.
Okay.
Getting it? Like I am now sure that you all must have understood the approach, how to approach this particular problem, right? So today your task is to try writing the codes for these if it is feasible. If not, then we will be writing the codes for these tomorrow. Clear?
Yes.
Okay, perfect. So I'll just be closing this right now. Just give me a minute. I'll just open the miscellaneous section so that you guys can. See, I have set of miscellaneous questions a lot. It's just that I want you guys to solve it parallelly with me. Okay, that's why I'm not sharing the list and all with for that. Did you guys got a chance to like code this up? Was it successful?
I have forgotten how to get a sub
Oh
array,
my
the
God.
first part. I was going through the beginning of sub-array examples.
Okay, did you found any? Did you found anything?
Yeah, the way was to just iterate of I, J, and K.
Mm-hmm.
But couldn't do that. Got stuck
For
up in.
this, you should take help from your group. The groups you have formed, take help from them now. Because I've explained now the subarray like 2 to 3 times, okay? So now you guys should be helping each other if you are forgetting these things. Okay, ask them, try to do it, and yeah. Okay, so if you're not like if you guys have not done it, I cannot move. Tomorrow I will discuss a more optimized solution to this. So those who have not still done it because there was a long gap, I could not take updates. Please do it by tomorrow. Tomorrow I'll explain the optimized solution. Okay. So thank you class for attending the session today. And yeah, try to do all the questions I explained today. Bye. Thank you.